Welcome to AI Decoded. I'm Emma Clark, and I'm thrilled to be your guide on this journey into one of the most transformative and fascinating technologies of our time, artificial intelligence. AI isn't just shaping industries and businesses, it's influencing the way we live, work, and interact with the world around us.
And I'm Michael Reynolds. Whether you're already an AI enthusiast, a tech professional looking to stay ahead of the curve, or just someone curious about the buzz surrounding AI, this podcast is for you. We're here to break down the complexities, demystify the jargon, and show you how AI is changing the world, one innovation at a time.
Our goal is simple: to make AI accessible and relatable for everyone. You don't need a PhD in computer science to understand this podcast. We'll take you through the basics, walk you through real-world applications, and explore what AI means for your career, your business, and your daily life.
That's right. AI is often painted as something futuristic or far removed from everyday life. But the truth is, it's already here. And it's working quietly behind the scenes in ways you might not even realize. From helping you unlock your phone with facial recognition to recommending the next show to binge watch on Netflix, AI is everywhere. And we want to show you how it works.
This podcast is designed to be engaging, practical, and easy to follow. We'll use relatable examples, current statistics, and stories from companies and innovators who are leveraging AI to solve real-world problems. Whether you're an entrepreneur looking to incorporate AI into your business or a parent curious about how AI is shaping your child's future, there's something here for you. We'll also tackle the big questions. What is AI? How does it work? How is it evolving? And perhaps most importantly, what does it mean for us as humans? From ethical dilemmas to the future of jobs, we'll dive into all aspects of this incredible technology.
And this isn't just about the technical side of things. We'll explore the human stories behind AI, how it's enabling new opportunities, raising important ethical concerns, and shaping the decisions we make as a society.
Each episode of AI Decoded is packed with insights, actionable takeaways, and thought-provoking discussions. And today, we're starting with the foundations. We'll explore the core concepts of AI, its history, and how it's integrated into our lives, often in ways we don't even notice.
In this episode, we're diving into the core concepts of artificial intelligence, breaking down what AI is, how it works, and why it's reshaping the world around us. Then, we'll step back in time to uncover the fascinating history of AI, tracing its evolution from early mathematical theories to today's groundbreaking advancements in deep learning.
From there, we'll explain the fundamentals of machine learning, the core technology that enables AI systems to improve over time. We'll dive into the role of data in AI, explaining how machines learn, the types of data they rely on, and why quality data is critical for accurate AI predictions.
Finally, we'll break down neural networks, the systems that power advanced AI applications like image recognition, language processing, and autonomous decision-making. By the end of this episode, you'll have a clear understanding of the key concepts driving AI and be better equipped to engage with this revolutionary technology.
So, are you ready to decode AI? Let's get started and embark on this exciting journey together.
Let's dive in.
To kick things off, let's answer the fundamental question: what is artificial intelligence, or AI? We hear the term all the time, but understanding what it really means is crucial.
AI refers to the ability of machines to perform tasks that would typically require human intelligence. These tasks include recognizing patterns, processing natural language, learning from experience, and making decisions. Unlike traditional software, which follows rigid, pre-programmed instructions, AI systems can adapt and improve over time.
To better understand AI, let's break it down into three main types: narrow AI, general AI, and artificial superintelligence. Each represents a different level of capability.
Narrow AI, also known as weak AI, is the kind we interact with most. It's designed to perform a specific task exceptionally well, but it can't do anything beyond that. A good example is Spotify's recommendation engine. It analyzes your listening habits and suggests music you might enjoy. In fact, Spotify's personalized playlists drive over 40% of user engagement on the platform.
Another example is Google Maps, which uses AI to analyze traffic data and calculate the fastest routes in real time. According to Google, their AI-powered navigation saves users over 1 billion hours of travel time every year.
In contrast, general AI, or strong AI, refers to machines that can understand and perform any intellectual task a human can do. It's still a theoretical concept, but researchers are working toward creating systems that can learn and reason across multiple domains.
If general AI becomes a reality, it could revolutionize industries by providing solutions to complex interdisciplinary problems. However, we're still decades away from achieving that level of intelligence.
And then there's artificial superintelligence, the idea of machines surpassing human intelligence in every way. While it sounds like science fiction, it raises critical ethical and societal questions, especially around safety and control.
Now, let's talk about why AI has become such a big deal in recent years. The first factor is the explosion of data. In the past 2 years alone, humanity has generated 90% of all the data ever created. AI thrives on data. It learns, adapts, and improves by analyzing it.
The second factor is computational power. Advances in hardware like GPUs and cloud computing have made it possible to train complex AI models. OpenAI's GPT-4, for instance, is one of the largest language models ever created, with 175 billion parameters. It can write essays, answer questions, and even create poetry, all powered by cutting-edge computation.
And let's not forget algorithmic innovation. Machine learning, particularly deep learning, has been a game changer. Deep learning uses artificial neural networks inspired by the human brain, allowing AI to process unstructured data like images, video, and audio. This is what makes image recognition and voice assistant so effective.
Take Google Photos, for example. Its AI can categorize your pictures by recognizing faces, places, and objects with remarkable accuracy. The technology analyzes billions of data points across millions of images, continuously improving its performance.
Another exciting area is natural language processing, or NLP. This enables AI to understand and generate human language. Virtual assistants like Siri and Alexa rely on NLP to process voice commands. According to Gartner, conversational AI systems handled 70% of customer interactions in 2022, saving companies billions annually in customer service costs.
AI isn't just about convenience, it's also driving real-world solutions. For instance, healthcare systems like Google's DeepMind use AI to analyze medical data. Their algorithm for retinal scans can detect over 50 eye diseases with an accuracy rate comparable to top ophthalmologists. This has reduced diagnosis times from weeks to just minutes.
To summarize, AI is a transformative technology powered by data, computational power, and advanced algorithms. From personalized music recommendations to breakthroughs in healthcare, it's reshaping the world around us. To truly appreciate where AI is today and where it's headed, we need to look back at its origins. The history of AI is a fascinating journey filled with groundbreaking discoveries, bold predictions, and lessons learned from both successes and setbacks.
Absolutely. AI didn't just emerge overnight, it's the product of decades of innovation and curiosity. By understanding its history, we can better grasp how far we've come and the challenges that shaped this transformative field.
The story of AI begins long before computers became mainstream. In 1950, British mathematician and computer scientist Alan Turing laid the groundwork with his seminal paper, Computing Machinery and Intelligence. He posed a simple yet profound question: can machines think?
Turing's idea of machine intelligence led to the development of the Turing test, which is still used today as a benchmark for evaluating whether a machine can exhibit behavior indistinguishable from a human. This concept became one of AI's foundational principles.
Turing wasn't alone. Around the same time, advances in computing made it possible to imagine machines that could process information like humans. For instance, in the late 1940s, Warren McCulloch and Walter Pitts developed the first mathematical model of neural networks, inspired by the way the human brain processes information.
This early research was theoretical, but it set the stage for practical experimentation. By 1956, the term artificial intelligence was officially coined at the Dartmouth Conference, organized by John McCarthy, Marvin Minsky, Nathaniel Rochester, and Claude Shannon. They envisioned creating machines capable of reasoning, learning, and solving problems.
The Dartmouth Conference is often referred to as the birth of AI as a formal discipline. Attendees made bold predictions such as achieving human-level intelligence within a generation. While overly optimistic, their vision ignited decades of research and innovation.
The initial wave of AI research in the late 1950s and 1960s saw the development of programs that could perform specific tasks, such as solving mathematical problems or playing games. For example, Arthur Samuel's Checkers program was one of the first to demonstrate machine learning by improving its gameplay through experience.
Another milestone was the creation of ELIZA in 1966 by Joseph Weissenbaum. ELIZA was one of the first chatbots, simulating human conversation by using pattern matching techniques. While it didn't understand the meaning of words, users still formed emotional connections with it, a phenomenon that foreshadowed modern interactions with AI like Siri or Alexa.
AI research wasn't confined to simple tasks. By the 1970s, researchers began developing expert systems designed to mimic the decision-making abilities of human experts. Programs like Dendril, which helped chemists identify molecular structures, and MySyn, which provided medical diagnoses, showcased the potential of AI in specialized fields.
Despite these achievements, the field faced significant challenges. The 1970s marked the first AI winter, a period of reduced funding and interest due to unmet expectations. Governments and organizations scaled back investments after realizing that human-level AI was far more complex than initially thought.
AI research experienced a resurgence in the 1980s with the rise of expert systems. These programs used rule-based approaches to solve problems in fields like finance, manufacturing, and medicine. For instance, the XCON system at Digital Equipment Corporation saved the company an estimated $40 million annually by automating computer configuration.
This period also saw the growth of neural networks, thanks to the backpropagation algorithm, which allowed networks to adjust weights and improve accuracy. Researchers like Geoffrey Hinton and David Rumelhart revitalized interest in this area, setting the stage for modern deep learning.
However, expert systems had limitations. They required extensive manual input to create rules, and their performance struggled with large datasets. As a result, the late 1980s and early 1990s saw another AI winter, as funding and enthusiasm waned once more.
AI's comeback in the 1990s was driven by advancements in machine learning. Instead of relying on hand-coded rules, machine learning algorithms learned from data. This shift was made possible by increasing computational power and the availability of larger datasets.
One of the most iconic moments in this era was IBM's Deep Blue defeating world chess champion Garry Kasparov in 1997. Deep Blue could analyze 200 million chess positions per second, showcasing AI's ability to handle complex tasks and strategy.
The internet boom in the 2000s accelerated AI's growth. Companies like Google began using AI to improve search results and deliver targeted advertising. This data-driven approach not only revolutionized business, but also demonstrated the practical value of AI in everyday life.
The 2010s marked a turning point for AI, driven by breakthroughs in deep learning. Neural networks with multiple layers enabled AI systems to process unstructured data, such as images, audio, and text, with unprecedented accuracy.
In 2012, Geoffrey Hinton's team won the ImageNet competition using a deep neural network called AlexNet. Their model drastically reduced error rates in image recognition and sparked widespread interest in deep learning applications.
These advancements extended to natural language processing as well. In 2018, OpenAI released GPT-2, followed by GPT-3 in 2020, both of which demonstrated AI's ability to generate coherent and contextually relevant text. GPT-3, with 175 billion parameters, has been used in applications ranging from customer support to creative writing.
AI also achieved new milestones in gaming. In 2016, Google DeepMind's AlphaGo defeated Lee Sedol, one of the world's top Go players, in a 5-game match. Go's complexity, with more possible board configurations than atoms in the universe, highlighted AI's ability to surpass human intuition.
Recent advancements include AI's role in drug discovery, with companies like DeepMind's AlphaFold predicting protein structures to accelerate medical research. This breakthrough has the potential to revolutionize our understanding of diseases and lead to new treatments.
Understanding AI's history helps us appreciate the dedication and innovation that brought us here. It's a story of visionaries, challenges, and breakthroughs, a reminder of how far we've come and how much more there is to explore.
Exactly. The journey of AI is ongoing, and its future depends on how we choose to develop and apply this incredible technology. As we move forward, learning from the past will guide us in making AI a tool for positive change.
Now that we've traced the fascinating journey of AI through its history, let's shift gears and explore one of the most transformative concepts within AI, machine learning. If the history of AI tells us how we got here, machine learning is what's driving us forward today.
Exactly. Machine learning, often referred to as ML, isn't just a subfield of AI. It's the engine that powers many of the applications we interact with daily. From recommendation systems to voice assistants, understanding how it works gives us insight into why AI has become such a game changer in recent years.
And what's fascinating about machine learning is how it flips the traditional approach to programming on its head. Instead of explicitly coding rules, we train machines to learn from data, allowing them to adapt, improve, and even make predictions. Let's break it down, starting with what machine learning really is.
At its core, machine learning is a method of teaching computers to learn from data rather than relying on hard-coded rules. It's about creating systems that can recognize patterns, make decisions, and improve over time based on experience.
A great way to think about it is by analogy. Imagine teaching a child to recognize animals. Instead of explaining every possible characteristic of a dog or a cat, you show the child pictures of each and let them figure it out by seeing patterns. Machine learning works in much the same way.
But there's a twist. These systems don't just memorize, they generalize. For example, a machine learning model trained on thousands of cat images can recognize a new cat it's never seen before as long as it shares similar characteristics with the training data.
There are three main types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Each serves a different purpose and is suited for specific kinds of problems.
Supervised learning is the most common type of machine learning. In this approach, the model is trained on labeled data, which means the input comes with corresponding output examples. Think of it like flashcards. You show the model a picture of a dog with the label dog, and over time, it learns to associate the two.
A real-world example is email spam detection. Gmail's spam filter uses supervised learning to analyze millions of labeled emails, spam or not spam, and learn the patterns that distinguish the two. This has resulted in over 99.9% accuracy in filtering unwanted emails.
Another example is predictive maintenance in manufacturing. Siemens uses supervised learning to analyze sensor data from machinery, predicting failures before they happen. This reduces downtime and saves companies millions in maintenance costs.
Unsupervised learning, on the other hand, works with unlabeled data. The system is tasked with finding hidden patterns or structures in the data. Think of it as giving someone a box of puzzle pieces without a picture of the final image. They figure it out on their own.
One of the most common applications is customer segmentation. Companies like Amazon use unsupervised learning to group customers with similar buying habits, enabling personalized marketing strategies. This has boosted Amazon's customer retention rates significantly.
Another fascinating example is anomaly detection. Credit card companies use unsupervised learning to flag unusual transactions, helping to prevent fraud. Visa reports that their AI systems save billions annually by identifying fraudulent activity, monitoring 500 transactions per second, identifying and preventing fraud with over 99% accuracy. This technology has saved the financial industry billions of dollars annually.
Finally, reinforcement learning involves teaching a system to make decisions by interacting with an environment and learning from feedback. It's like training a dog. You reward it when it does the right thing and withhold rewards when it doesn't.
In the real world, reinforcement learning is used in robotics to teach machines how to walk, grip objects, or navigate obstacles. It's also the backbone of self-driving car systems, where AI learns to make split-second decisions for safe navigation. One of the most fascinating aspects of AI is its ability to learn and improve, unlike traditional systems, which need to be manually updated. AI adapts based on new data. For example, Tesla's self-driving cars collect and analyze data from millions of miles driven, continuously refining their performance.
For machine learning to work effectively, three key components are required: data, algorithms, and computational power.
Data is the lifeblood of machine learning. The more high-quality data a system has, the better it can learn. However, as we've discussed, biased or incomplete data can lead to flawed outcomes. So, data quality is crucial.
Next, we have algorithms. These are the mathematical rules and procedures that guide the learning process. For instance, linear regression is a simple algorithm used to predict outcomes based on numerical data, while deep learning algorithms handle complex, unstructured data like images or text.
Finally, computational power is essential. Training advanced machine learning models requires immense processing capabilities. Today, this is made possible by GPUs, TPUs, and cloud computing platforms like AWS and Google Cloud.
We've just explored the basics of machine learning and how it powers modern AI systems. But there's one crucial ingredient we need to examine in more detail: data. If machine learning is the engine driving AI, then data is the fuel that keeps it running.
Exactly. Without data, AI systems would have nothing to learn from. Data is the foundation for every prediction, recommendation, and decision made by AI. To truly understand how AI works, we need to look at how it processes, learns from, and relies on data.
And this isn't just about having lots of data, it's about having the right data. Let's break this down and explore why data is so critical, how it's used, and the challenges it presents.
Artificial intelligence systems learn by analyzing patterns in data. For example, if you're training a system to recognize handwritten digits, you need a dataset with thousands, or even millions, of examples of numbers written in different styles. This helps the AI generalize and recognize numbers it hasn't seen before.
The importance of data can't be overstated. According to an MIT Technology Review report, 80% of an AI project's time is spent on gathering, cleaning, and organizing data. That's how fundamental data is. It's not just part of the process, it is the process.
And the impact of high-quality data is evident in every field. For example, Tesla's self-driving cars have driven over 20 billion miles, collecting data that feeds back into their AI models to continuously improve navigation and safety. This volume of data is what gives Tesla a significant advantage over competitors.
Let's talk about the types of data that AI uses. Broadly speaking, data can be categorized into two types: structured and unstructured.
Structured data is highly organized and fits neatly into tables or databases. Think of a spreadsheet with columns for names, dates, and transaction amounts. This type of data is commonly used in applications like fraud detection, where systems analyze financial transactions for anomalies.
On the other hand, unstructured data is messy and doesn't fit neatly into rows and columns. This includes images, videos, audio files, emails, and social media posts. Unstructured data makes up over 80% of the world's data, according to IBM, and requires advanced AI techniques like deep learning to analyze.
For example, Google Photos processes billions of images to help users organize their photo libraries. It uses unstructured data, photos, and applies computer vision to identify faces, places, and objects.
In the healthcare sector, unstructured data like medical scans or doctor's notes are being analyzed by AI to detect diseases and suggest treatments. For instance, Path AI uses medical imaging data to assist pathologists in diagnosing cancer with greater accuracy.
AI learns through a process called training. In supervised learning, the AI model is fed labeled data, where each input has a corresponding output. For example, training a chatbot might involve providing thousands of conversation examples paired with appropriate responses.
In unsupervised learning, the model works with unlabeled data, searching for patterns and relationships. For example, Spotify's recommendation engine clusters users with similar listening habits to suggest new music, even if the users themselves haven't labeled their preferences.
The process of learning doesn't stop after training. AI systems often go through continuous learning, using real-time data to improve. Amazon's recommendation algorithms, for instance, are constantly updated based on user behavior, ensuring they remain relevant and effective.
Looking ahead, the role of data in AI will only grow. Technologies like the Internet of Things, IoT, are generating unprecedented amounts of real-time data from smart devices, connected cars, and industrial equipment. AI systems will need to process and analyze this data efficiently to unlock its full potential.
Quantum computing is another game changer. As quantum computers become more capable, they'll enable AI to analyze larger and more complex datasets, solving problems that are currently beyond the reach of classical systems.
Data isn't just the backbone of AI, it's the key to its success. But with great power comes great responsibility. By prioritizing data quality, addressing bias, and respecting privacy, and we can ensure that AI serves as a tool for progress and innovation.
Next, we'll dive into the fascinating world of neural networks and how they mimic the human brain to process complex information. A neural network is a system of interconnected layers of nodes, or artificial neurons, that process information. Each neuron receives input, performs a calculation, and passes the result to the next layer of neurons.
Think of it like a factory assembly line. Each station or neuron performs a specific task, analyzing, transforming, or refining the information before sending it to the next station. By the end of the line, the system produces a final output, whether it's identifying an object in a photo or predicting the next word in a sentence.
Neural networks are particularly effective for handling unstructured data like images, videos, and text. They're the backbone of technologies like image recognition, speech-to-text conversion, and language translation.
Neural networks learn through a process called backpropagation. Initially, the network makes a prediction. If the prediction is wrong, the system calculates the error and adjusts the weights of the connections between neurons to reduce that error. This iterative process continues until the model becomes highly accurate.
It's similar to how humans learn. Imagine you're learning to hit a baseball. The first few attempts might miss the mark, but with feedback and practice, you adjust your stance and timing, improving over time. Neural networks operate in a similar way, fine-tuning themselves with each iteration.
Neural networks come in various types, each tailored to specific tasks. Let's break down a few key examples.
Convolutional neural networks, or CNNs, are specialized for image and video recognition. They work by breaking an image into small pieces, analyzing each one for patterns like edges or textures, and then combining this information to identify objects.
CNNs are used in applications like facial recognition, where systems like Facebook's DeepFace achieve over 97% accuracy in identifying individuals. They're also critical in healthcare, where AI analyzes medical images like X-rays or MRIs to detect abnormalities.
For example, Google's DeepMind uses CNNs to identify over 50 types of eye diseases with accuracy comparable to top specialists. This technology has already helped save the vision of thousands of patients.
Recurrent neural networks, or RNNs, are designed to handle sequential data, such as time series or text. They're especially useful for tasks like language modeling and speech recognition.
One prominent application is predictive text. When your smartphone suggests the next word as you type, it's likely using an RNN trained on vast amounts of text data. Apple's QuickType and Google's Gboard both rely on this technology.
RNNs are also used in financial forecasting. Companies like JP Morgan employ these networks to analyze stock price trends and predict market movements, providing actionable insights to traders.
A more recent advancement is transformer networks, which have revolutionized natural language processing. Unlike RNNs, transformers process entire sentences at once, capturing long-term dependencies and context.
Transformers power AI models like OpenAI's GPT-3 and Google's BERT. These systems generate human-like text, translate languages, and even write code. For instance, GPT-3, with its 175 billion parameters, has been used to draft articles, create chatbots, and assist developers.
Transformers have also made AI-powered customer support more seamless. For example, chatbots on e-commerce websites like Shopify can handle inquiries with contextual accuracy, improving user experience and reducing support costs.
Neural networks are behind some of the most innovative AI applications we interact with daily. Let's look at a few standout examples.
In transportation, neural networks process data from cameras and sensors in autonomous vehicles. Tesla's neural network enables its cars to identify pedestrians, traffic signs, and road conditions, making real-time decisions to ensure passenger safety.
In entertainment, Netflix uses neural networks to recommend shows and movies based on your viewing history. Their recommendation engine accounts for over 80% of the content users watch, demonstrating the power of personalized AI.
Healthcare is another area where neural networks shine. IBM's Watson Health analyzes patient data and medical literature, assisting doctors in diagnosing diseases and recommending treatments. This technology has improved diagnostic accuracy for cancer by up to 20% in some cases.
And let's not forget creative applications. Tools like deepart.io use neural networks to transform photos into artwork inspired by famous painters. Similarly, neural networks power AI music composition platforms like Amper Music, enabling users to create original soundtracks.
We're also seeing exciting developments in generative adversarial networks, GANs. These networks create hyper-realistic images, videos, and even voices, opening new possibilities for industries like entertainment and design.
We've traced the fascinating history of AI and its fundamental components. AI isn't just something that exists in research labs or tech companies, it's woven into the fabric of our daily lives. Let's start with your morning. Imagine your alarm clock goes off, and your smart assistant reminds you of today's appointments, the weather, and traffic conditions, all tailored to your schedule. That's AI in action.
Smart home devices like Amazon Echo and Google Nest use AI-powered voice assistants to provide personalized updates and control connected appliances. By analyzing your preferences and habits, these systems learn when to adjust your thermostat or suggest reminders.
Even the news you check over breakfast is likely curated by AI. Platforms like Google News and Flipboard use recommendation algorithms to highlight stories based on your reading history. According to a study by Reuters, 75% of people now consume news personalized by AI.
Your commute is another area where AI plays a critical role. Navigation apps like Google Maps and Waze use AI to analyze real-time traffic data and recommend the fastest route to your destination.
And if you're using a ride-sharing app like Uber or Lyft, AI is optimizing everything from route selection to dynamic pricing. In fact, Uber's AI system predicts demand spikes with up to 90% accuracy, ensuring drivers are positioned where they're needed most.
For those who drive electric vehicles, AI systems in Tesla and other cars optimize battery usage and even assist with semi-autonomous driving. Tesla's autopilot, for instance, uses neural networks to analyze road conditions and make real-time decisions, covering over 20 billion miles of driving data to date.
When you log on to work, AI doesn't take a break. Email clients like Gmail use AI to filter out spam and suggest quick replies through Smart Compose, saving users an estimated 1 billion hours annually.
In virtual meetings, platforms like Zoom and Microsoft Teams deploy AI for features like noise cancellation, real-time transcription, and even virtual backgrounds. These tools enhance productivity and ensure smoother communication.
For professionals dealing with large datasets, AI-powered tools like Tableau and Power BI help analyze and visualize data, turning raw numbers into actionable insights. These systems use natural language processing to let users ask questions like, "What were last quarter's sales trends?" and get instant answers.
When the workday ends, AI continues to enrich your life. Think about how platforms like Netflix, Spotify, and YouTube recommend content you'll love. These systems analyze your preferences, past interactions, and even the time of day to suggest what's most relevant.
Netflix's recommendation engine, for example, accounts for over 80% of the content viewers watch. It uses AI to analyze billions of viewing patterns and predict what you'll enjoy next. Similarly, Spotify's Discover Weekly playlists are curated by analyzing your listening habits alongside those of similar users.
Even gaming is being transformed by AI. Titles like The Last of Us, Part 2, and Red Dead Redemption 2 use AI to create realistic non-player characters, NPCs, that adapt to player actions, enhancing the overall gaming experience.
Let's not forget shopping. Platforms like Amazon use AI for everything from personalized product recommendations to dynamic pricing. AI has helped Amazon achieve an estimated $21 billion in additional annual revenue through better targeting and inventory optimization.
When you look at all these examples, it's clear that AI isn't just a futuristic concept. It's here. and it's enhancing our lives in countless ways. But what makes it truly powerful is its ability to adapt, learn, and personalize experiences based on individual needs.
And remember, the journey doesn't stop here. AI is constantly evolving, with new developments emerging every day. Staying ahead means staying curious. Read, explore, and most importantly, ask questions. The more we engage with AI, the more we shape its future, not just as consumers, but as active participants.
If you enjoyed today's episode, make sure to subscribe so you never miss an update. And if you found value in our discussion, share it with friends, colleagues, or anyone curious about the impact of AI. Spreading awareness is one of the most powerful ways to create a better understanding of this transformative technology. Until next time, keep exploring, keep questioning, and keep decoding AI. This is Emma Clark.
And Michael Reynolds signing off from AI Decoded. See you in our next episode.